Delete at head means, for example, this of course everybody knows is my head, and this would be my tail, and this has a null right here. So now when I want to delete at head, we're gonna have to push our head to the next side, right? There's gonna be a 3-step process. One is going to be you create a temp node, alright, and you make it equal to head. Okay, so I'm gonna say create T. Second step is going to be that you take your head, you push it to the next node. Okay, so now head moves over here. Okay, so I'm gonna say here move head to the next node, and then the next third step would be to automatically delete T. So I'm gonna say delete this node, and the only way you can tell in a linked list or in a like programming language to delete this node, I mean had you moved it to the other side, so your reference is now lost. Now that's where T comes in. We have to tell it to delete T, and once we delete T, it's gonna delete this. So that's just how the process is. So now let's code it out. So once I delete at head, first step was to create a temporary node and make it equal to head. Done. After that, I'm gonna make head move on to the next node. Okay, and I'm gonna make it equal to head. So I'm incrementing head. Let's hold on. Head is equal to head.next. Done. That's step 2. Step 3 is going to be simple. You know how to delete a pointer. If you don't, you can watch my programming fundamental videos on pointers, and that's gonna just delete our node there. Simple as that. However, there are edge cases. For example, firstly, if our linked list is empty, okay, so we're gonna have to check for that. If head is equal to null, and why we checking for this? Because if we don't and our linked list is empty, then it's gonna give us an error. It's gonna say what is there to delete? Head is null, so how can we delete head again? So we're going to say just return. Perfect. If head is null, do nothing, just return. Thanks for watching.